Okay, let's take a look at section 3.5. So in the last video, I said that there's a couple different ways to write an equation. And the first way is to use y equals mx plus b. And to be honest, if this is your preferred method, that's perfectly fine. As long as you can write an equation, I don't care if you use this method or the method that we're going to use today. So whichever way gets you to a written equation, perfectly fine with me, although I do have to teach you this. So let's get to it. Point slope form, it's a new form. So we have standard form, ax plus by, excuse me, standard form. We use this for if we're solving systems of equations, which we're going to do in chapter 4. Sometimes when we have an application problem, it might be easier to write an equation like this, but most of the time not. Okay, so then we have slope-intercept form, and y equals mx plus b. And again, sometimes it's easier to write an equation if an application problem in slope-intercept form. A lot of it just depends on the application that we have. And is also much easier to graph when it's in slope-intercept form. Okay, so this is used for a lot of stuff. This is used for a lot of stuff. We have a third method, which is called point slope form. Not a third method, a third form, which is called point slope form. It's point slope form. This is good for one thing and one thing only. The only thing it does is write equations. That's all we use it for. We don't use it for anything else. Standard form, we use it for lots of different stuff. Slope-intercept form, we use it for lots of different stuff. Point slope form, the only thing we use it for is to write an equation. And typically this is how we write equations. So yes, you can write an equation using y equals mx plus b, but that's traditionally not how teachers teach it. It's, yeah, to be honest, I'm not sure why we don't just use this, but whatever. Okay, so write an equation of the line passing through this point with this slope. Give the answer in slope-intercept form and standard form. So we want both, okay? This right here is not typically how they ask the question, okay? Let me show you how they typically ask the question. They usually say this: write the standard form of equation through this point with this slope. Okay, so a lot of students see this word standard form and think they have to actually use standard form to write the equation. That is completely false. You cannot write an equation like this using standard form. Okay, so I know I said that you can do an application problem sometimes. We're not there yet. Okay, so just put that out of your head. Standard form, you do not write equations using standard form. One more time, you do not write equations using standard form. So what we're going to do is ignore the fact that it says write the equation in standard form, or ignore the fact that it says write the equation in slope-intercept form, and go straight to slope, or sorry, point slope. And I should pay attention to what I'm doing. Y sub 1, m, x, there we go. Okay, so this is going to be a number from our ordered pair. This is going to be a number from our ordered pair. And this is going to be a number from our slope. X is going to stay as a variable x, and y is going to stay as a variable y. So our y value is 2. Our m is negative 1/3. And our x value is 5. Okay, So y minus 2, distribute. We never, ever, ever, ever leave our answer in this form. It's always going to be, our answers are always going to be either in slope-intercept form or standard form. In this case, we need both. Now, remember, when you're multiplying a fraction times a whole number, you multiply the top, you multiply the bottom, right? Now, we need to add 2. We need a common denominator. So we're going to multiply top and bottom by 3. So we have 5 plus 6. Okay, so here is our slope-intercept form, right here, slope-intercept form. Now we need our answer in standard form as well. So we need the x and y on the same side. So we're going to add 1/3 x. The x has to be positive, which it is. No fractions, no decimals. So remember, to get rid of the fractions, we multiply by the least common multiple of the denominators. So we've got 3, we've got 1, we've got 3. So we're going to multiply by 3, which allows me to cancel. And I have 1x plus 3y is equal to 11. And here is my answer in standard form. All right. Okay, so let's suppose instead of them giving us the slope, m equals whatever, and a point, they instead give us 2 points. Okay, so we're given 2 points. In order to be able to use point slope form, we need a point and the slope. We've got a point. As a matter of fact, we've got 2 points. What we don't have is the slope. However, we have enough information to be able to write an equation. We have enough information to be able to find the slope using our slope formula. So if they don't give us the slope, we have to find it ourselves. In this case, we're going to take 6 minus 5, negative 1, subtract 2. Gives me 1 over negative 3, pure coincidence that we happen to get the same slope as the last slide. All right, so we have a slope of negative 1/3. Now, we also need a point, right, to substitute for our x and our y, right here and right here. We can pick either point, either one, doesn't matter. We'll get the same answer in the end. But if we can choose either one, we generally pick the easier one, whichever one that looks easier to you. If we have positive numbers, that's generally easier. If we have smaller numbers, that's generally easier. So this has a negative, so I will probably pick this point to use in my formula. But it doesn't matter. You will get the same answer regardless, assuming you do your math correctly. So we're going to subtract our y value, which is 5. We are going to substitute in our m, x minus our x value of 2. We're going to simplify this. We're going to multiply. Remember, multiply the top, multiply the bottom. Okay, so add 5. Need a common denominator. So I'm going to move this out of the way real quick. Okay. So we have y is equal to negative 1/3 x plus, so 5 times 3 is 15 thirds plus 2 thirds is 17 thirds. So this is my answer for part A. And then for part B, I need to get the x and the y on the same side. So I'm going to add 1/3 x to both sides. My x has to be positive, which it is, and no fractions or decimals. So I have a denominator of 3. So least common multiple is 3. Cancel. And I have x plus 3y is equal to 17. And there we go. Same idea. Actually, I think it's the same question. Example 2, it's the same question, sorry. All right, I am going to stop here and I am going to pick this up in another video.